In order to get the solve function to take into account all of the neighboring walls, we're going to do something similar to what we did in order to get it to update all of the neighboring cells. The first step of that process was to figure out where the cells were in relation to a target cell. So right now we're going to figure out where the walls are in relation to our target cell. So if I have a wall to the north, I am going to first figure out what the coordinates of this target cell are. And if you remember from previous videos, it's row 0, row 1, row 2, and column 0, 1, 2, 3, 4. And then the coordinates of this north wall were 0, 1, 2, so row 2, and column 0, 1, 2, 3, 4. So the coordinates of the cell and the coordinates of the north wall turn out to be the same. If we look at the east wall, the west wall, we'll find that the coordinates of this wall are also the same. Here's the 0, 0 vertical wall, row 1, row 2, and then column 0, column 1, column 2, column 3, column 4. I'm going to put in kind of a bluish color here the difference between these coordinates and the target cell's coordinates, which are, it's nothing. It's 0, 0. There's no difference at all. Now it's time to look at the east and the south walls. So the east wall here, it's the same row as the west wall, but it's one more column over. So the coordinates of this wall are 2, 5. Or the difference would be 0 rows and 1 column, plus 1 column. If I look at the south wall, I'm in the same column, but I am now 1 row further. So here, the difference is plus 1 row, but I didn't move any columns. So if I make a neighboring walls array similar to the neighboring cells array that I made a couple videos back, it'll look something like this. The 0th row of this array, which equates to the north wall, would have values of 0, 0. The first row, which equates to the east, would equate to 0, 1. The south wall, row 2, would be plus 1 row, plus 0 columns, and the west wall we're just going to add a 0 and a 0. To add this array to our program, I'm going to scroll to the top of my Nano Mouse Maze class and then slide down just a little bit to put it right underneath our neighboring cells array. I'm making it a byte this time because none of these values are negative. And it has the same dimensions, 4 rows and 2 columns. And I'm going to declare it pretty much the exact same way. And then I'm closing the array. That's the matching ellipse here. And I need to finish it with a semicolon. Again, if I hit Control T to try and make everything look pretty, you will see that it completely messes it up. But as I said before, it's okay, it's functional, it will work. Now we're going to scroll down to the solve function. And we're looking inside the loop that goes through every direction, the K loop. And here I didn't add anything to the I term, the row term, and I didn't add anything to the J term, the column term. But here, when I'm looking at the neighboring cells, I added something. So when I'm looking at the neighboring walls, I should also add something, and it's going to be from the neighboring walls array. It's actually going to be pretty much the exact same thing. It's just pulling from a different array. So most of the time, the values that are being added are 0. The only time that anything else is being added is when we go through k the second time, when k is a 1, then the value of the j term is a 1, the column term is a 1, and then when I go through it when k is equal to 2, the I term gets a 1 added to it. Now that I have these two terms being added to I and j, the neighboring wall row and neighboring wall column values are valid no matter what the value of k is. It used to be that they were only valid when k equaled 0, but now they're valid when k is 0, 1, 2, or 3. So I actually wouldn't need this condition here, except that I need to know which array to pull from based on whether or not I'm looking at a horizontal wall or a vertical wall. So whenever I'm looking at horizontal walls, that's going to be a north wall or a south wall, and else I must be looking at an east or west wall. In which case, I'm going to do the exact same thing. I'm going to determine if a wall exists by pulling the information from a walls array, but it's going to be the vertical walls array. After making these changes, go ahead and upload the program to your Arduino and see how it works. Everything is functioning just as we want. The value north of the target cell is not being updated because there's a wall to the north. The value to the west of the target cell is not being updated because there's a wall to the west. But all of the other cells are being updated, just like they're supposed to be.